Hey everyone, ready for a deep dive that'll really make you think?
Oh, I think this one's going to be fun.
Today we're tackling Nicolaus Copernicus.
The guy who basically said, nope, Earth is not the center of everything.
It's kind of wild to think how much he changed our view of, well, the whole universe.
You know, people might be listening, getting ready for a big presentation on astronomy.
Or just super curious about how we figured all this stuff out.
Exactly. And luckily, we've got this great article from National Geographic to guide us.
So we're going to unpack how Copernicus developed his heliocentric model. That's the sun at the center, for anyone who's not sure.
Right. And you got to realize, for centuries, the geocentric model was like the truth.
Yeah.
Everyone believed it.
Earth as the big stage, everything revolving around us.
Scientists, philosophers, the church, they all agreed.
It's almost impossible to imagine thinking that way now, isn't it?
It really is. It shows you how revolutionary Copernicus's ideas were.
Yeah, like imagine thinking the world is flat.
Hmm.
And someone's like, nope, it's a sphere.
That's a good comparison. This was like the space version of that.
So, to understand his impact, let's start with Copernicus's background.
Born back in 1473 in Turów, Poland. Busy city, known for trade. His family was in commerce.
But the real turning point was his uncle, right?
Oh yeah, Lucas Watson Road.
Yeah.
Huge influence on Copernicus.
Became the Bishop of Warmia.
Guided him towards a religious career, believe it or not.
Wait, seriously? How'd that lead to astronomy?
Well, back then the church was really involved in education, scholarships, all that.
Ah, so Lucas made sure Copernicus got a top-notch education.
First at a local parish school, then the big one, Academy of Cracovia. Today it's Jagiellonian University.
Over 2,000 students. Must have been a buzzing place.
Real intellectual hub. And he had professors like Wojciech de Brudzowo and Jan de Glogo.
They really pushed him to think critically, especially about astronomy.
Exactly. They didn't want him just accepting stuff blindly.
Which is kind of funny because back then there were already cracks showing in that whole Earth-centered model.
Yeah, there were these two camps. The naturalists, they took Aristotle as gospel. Earth is still at the center, no question.
Then the mathematicians, they used Ptolemy's Earth-centered model more like a tool.
Right, like a way to predict where the planets would be, but not necessarily the real truth of it.
So Copernicus was exposed to these different viewpoints from the get-go.
Yeah, made him question things. But then his awesome uncle steps in again.
Sends him off to Italy.
The Italian adventure. Bologna, Rome, Padua.
Soaking up all that Renaissance knowledge.
In Bologna, he really got into studying Greek.
So he could read the ancient astronomers in their own words.
Exactly. That's where he met Domenico Maria Novara.
An astronomer who really focused on observation.
And they worked together. Copernicus wasn't just some student taking notes.
That's so cool. They did astronomical observations together.
Like a real partnership. Both looking at the stars, trying to figure it all out.
And Copernicus was making his own observations too, right?
Oh, yeah. In Rome, during the Jubilee year in 1500, he observed a lunar eclipse.
So he's putting all this learning into practice.
And then he goes to Padua, and get this, shifts his focus to medicine.
Whoa, medicine. But he kept up with astronomy and Greek too.
This is what makes him such a Renaissance man. And medicine was changing a lot back then too, you know.
It's like he's surrounded by this energy of challenging the old ways, not just in one field, but in multiple.
Yeah, like everything's up for grabs, let's question it all. And that mindset really set the stage for what Copernicus would do next.
Okay, I am officially intrigued. We're going to have to pick this up in the next part of our deep dive to see where Copernicus takes all this.
You won't believe what he figures out next. But before we get to that, we need to kind of understand what everyone else thought back then.
Yeah, that whole Earth-centered thing.
Exactly. For centuries, the geocentric model, that was it.
It's hard to imagine now, though.
I know, right?
Like Earth is the unmoving center and everything else just circles around us.
Right. And this model was based on the work of Ptolemy. He was this Roman astronomer who lived way back in Alexandria, Egypt.
Oh, wow.
Yeah. And he came up with this incredibly complex system to explain, how the planets moved, but all based on Earth being still.
And that's where those epicycles and deference come in, right?
You got it.
To be honest, those always kind of confuse me.
They are a little tricky.
Yeah.
Imagine you're trying to figure out why a planet would look like it's moving backward, that whole retrograde motion thing.
Retrograde motion, yeah. Why would a planet suddenly, make a U-turn?
It doesn't make a lot of sense if you assume Earth is the center, right? So Ptolemy's solution was to add these smaller circles, called epicycles, onto the planet's regular orbits, which were called deferents.
Okay, wait, so a circle? On top do you have another circle?
Exactly. You can think of it like a Ferris wheel, okay? The big Ferris wheel, that's the jet
Yep,
frames.
okay, get it.
Then on one of the cars, imagine there's another smaller Ferris wheel spinning.
Okay, I'm visualizing it.
That's the epicycle. And the planet is actually on that smaller wheel. So its motion is a combination of both spinning motions.
Whoa, okay, I'm starting to get it.
Yeah, so basically the planet's doing this double loop-de-loop, which explains why sometimes it looks like it's going backward from our perspective.
That is super complicated, though.
It was. Ptolemy needed, get this, up to 90 of these epicycles in deference to make his model work and accurately predict the planet's positions.
90 circles, just to describe how planets move. No wonder Copernicus wanted something simpler.
Exactly. It was just so complex. But, Copernicus wasn't the first one to think about a sun-centered system.
Really? Someone else had that idea before him.
Way before him, like all the way back to ancient Greece, there was this astronomer, Aristarchus of Samos, who lived in the 3rd century BC.
Wow.
And he came up with a model where the sun was at the center.
So the idea was already out there.
It was. And there were others who kind of dabbled in similar ideas too.
Like who?
Well, there was Hicetus, Heraclides, Seleucus, even some Islamic scholars like Al-Hasan. They all questioned the geocentric view.
Interesting. So Copernicus wasn't working in a vacuum. He was picking up on this thread of doubt that had been around for a long time.
Yeah. You got it. And it all kind of comes to a head around 1507 when Copernicus writes this short treatise called Commentariolus.
Commentariolus, okay?
Yeah. And in it, he lays out his heliocentric theory. But, and this is important, he only shared it privately, just with a few trusted friends and colleagues.
Makes sense. I mean, he was challenging centuries of accepted truth.
Exactly.
That's
It was
a lot.
risky stuff.
It's like he's testing the waters before jumping all the way in.
I think you're exactly right. But even in this early work, you see the core of his theory. He's already saying that Earth rotates on its axis, revolves around the sun. A&D has a third motion to explain. It's kind of complicated. The precession of the equinoxes.
Hold on, 3 motions. Rotating, revolving, and what was that third one?
Precession. It's basically a slow wobble of Earth's axis over time.
Okay, so like a spinning top, kinda. As it spins, its axis also slowly wobbles.
Yeah, that's a good way to think about it.
Yeah.
And Copernicus realized this wobble was needed to explain some of the longer-term changes in the star's positions.
Wow, he was thinking really long term.
He was. And he wasn't just guessing either. Copernicus was really good at observing those tiny, subtle changes in the sky and figuring out what they meant.
So we've got Copernicus back from Italy, full of new ideas, and he's developed this revolutionary theory, but he's keeping it pretty hush-hush for now.
For now, yes. He goes back to Poland, takes up his duties as a canon in Fromborg.
So he's got this day job dealing with church stuff.
Yeah, but all the while, he's got this mind-blowing theory about the universe just simmering away.
Must have been an interesting time for him. All quiet on the outside, but inside, it's like a scientific revolution is brewing.
That's a great way to put it.
Yeah.
But even with his duties in Fromborg, Copernicus keeps up his astronomy. We know he was writing letters to other astronomers, debating ideas and stuff.
Oh, really? Like with who?
Well, there's this one letter from 1524 that he wrote to Bernard Łapowski.
Okay, what's so special about this letter?
Well, in it, Copernicus is arguing against another astronomer, Johannes Werner, who was studying the motion of the stars. And what's so fascinating is that Copernicus really knew his stuff. He was deep into the math, the observations, all of it.
So he's not just some guy with a wild theory. He's actually engaging in real scientific debate using data and evidence.
That's exactly it. He's taking on other experts, refining his arguments, and really showing that he understands the complexities of astronomy.
This letter is like a window into his thought process, huh?
Yeah, I think so. And all of this is building towards his big work, the one that would really change everything. It's called De Revolutionibus Orbium Coelestium, which means On the Revolutions of the Heavenly Spheres.
That's the book, right? The one that really sets off the Copernican revolution. But
Yeah.
It took him years to write it, didn't it?
It did, years and years. And it wasn't just about the research, which was obviously massive. There was also a huge element of fear involved.
Fear, like he was afraid to publish it.
Yeah, I mean, think about it. He was challenging the church, the whole accepted view of the universe, and that was dangerous territory back then.
He could have been ridiculed, ostracized.
Even worse. So he hesitated, double-checking his work, gathering more evidence, maybe just trying to work up the courage.
It's a good thing he did eventually publish it, though. So, De Revolutionibus finally comes out. Let's break down exactly what his heliocentric model says, because I gotta admit, I could use a refresher.
Sure. So Copernicus's model is actually pretty elegant. It puts the sun at the center, and the Earth, along with the other planets, revolves around it.
Okay, that's straightforward enough.
Right. Then he explains day and night by saying that Earth spins on its axis, rotating.
Like a basketball spinning on your finger.
Exactly. And then he adds in that third motion, the precession, to account for some of the longer-term changes in the star's positions.
So much simpler than Ptolemy's model with all those crazy epicycles.
Oh, way simpler. But it wasn't perfect. Copernicus still used circular orbits for the planets, and even needed a few of those epicycles himself to make everything match the observations perfectly.
Wait, he still needed epicycles? I thought those were gone.
Well, not entirely. He needed far fewer than Ptolemy, though. And remember, even with his model, there were still some things they couldn't explain back then.
Like what?
Well, one big problem was stellar parallax.
Stellar parallax. I don't think I've heard of that.
It's basically this. If Earth is moving around the sun, the position of the stars should look slightly different depending on where Earth is in its orbit. Like if you close one eye and then the other, the position of your thumb seems to shift compared to the background.
Oh, I get it. So they should have been able to see that tiny shift in the stars' positions.
Right, but they couldn't. Their instruments weren't accurate enough back then. So Copernicus argued that the stars were just too far away for this parallax to be noticeable.
Which turned out to be true, right? Stars are incredibly far away.
Yeah, but at the time, it was a hole in his theory, something that critics were quick to jump on.
So, De Revolutionibus comes out. What's the reaction? Is everyone immediately on board with this whole sun-centered universe thing?
Oh, not at all. It was a mixed bag. Some astronomers were interested, intrigued by the idea.
But others were probably like, this guy's crazy.
Basically, there was a lot of skepticism. And then there was the church. Initially, they didn't make too much of a fuss, partly because of this preface that was added to the book.
The preface. Who added that?
A guy named Andreas Osiander. He was a theologian who helped get the book published. And in this preface, he basically says that the heliocentric model is just a hypothetical tool, a way to make calculations easier, but not necessarily a description of reality.
Smart move. Downplaying the whole sun at the center thing.
Yeah, it probably helped avoid some immediate backlash. But even with the preface, Copernicus's work had a huge impact. It really got people thinking and questioning the old ways of seeing the universe.
It's like he planted the seed, and from that seed, a whole new way of understanding the cosmos would eventually grow.
Exactly. You can't underestimate how important that was.
It really makes you think, One guy, working quietly in Poland, comes up with this idea that completely changes how we see the universe.
And he wasn't even, in a big university or anything. Just shows you amazing ideas can come from anywhere.
Totally. And then, of course, you've got all the scientists who came after Copernicus. Galileo, Kepler, Newton. They all took his work and ran with it.
Oh, yeah. They wouldn't have been able to do what they did without him. Think about Galileo. He builds a telescope and starts looking at the sky.
And sees things that blow everyone's mind.
Exactly. Phases of Venus, moons orbiting Jupiter. These were things that the old Earth-centered model couldn't explain.
And that's what got him in trouble with the church, right?
Yeah, sadly. Challenging their view of the universe was a big no-no back then. But even with the church pushing back, the heliocentric model was gaining traction.
It's like once the idea was out there was no putting it back in the box.
Nope. And then you have Kepler. He takes all this incredibly detailed data that Tycho Brahe had collected about the planet's movements.
Wasn't Brahe, super meticulous with his observations?
Oh, yeah. He was known for his accuracy.
Yeah.
And Kepler uses that data to refine Copernicus's model even more. That's where the elliptical orbits come in.
Elliptical orbits. So not perfect circles.
Right. Planets don't move in circles around the sun. They move in these slightly squashed circles, these ellipses.
Interesting. I wonder why that is.
Well, that's where Newton comes in. He figures out the whole gravity thing and how it affects the planet's motions.
Ah, right. Gravity. Everything's attracted to everything else.
Exactly. And the sun, being so massive, exerts a huge gravitational pull on the planets, keeping them in orbit. But those orbits aren't perfectly circular because of the planet's own velocities and the interactions with other planets. It's pretty complex, but Newton's laws explain it all beautifully.
So Copernicus gets the ball rolling, Kepler refines the model, and Newton explains the underlying WHY.
It's a perfect example of how science works. It's a collaborative effort. You build on what came before, keep testing and refining, and eventually you get a better understanding of how the universe works.
It's pretty amazing when you think about it. And it all goes back to that one guy, Copernicus, who had the courage to say, hey, maybe we're not the center of everything.
And that courage sparked a revolution that's still going on today. We're still discovering new things about the universe, pushing the boundaries of knowledge further and further.
It makes you wonder what other truths we accept now might turn out to be completely wrong.
Oh, I'm sure there are plenty. The universe is full of mysteries, and who knows what future scientists will uncover.
Well, on that note, I think we've reached the end of our deep dive into the life and work of Nicolaus Copernicus.
From his early days in Poland, to those exciting times in Italy, to finally publishing his groundbreaking book, De Revolutionibus.
We've covered a lot of ground, and hopefully everyone listening has a better appreciation for how much Copernicus changed our understanding of the universe.
And how his courage to challenge the status quo paved the way for centuries of scientific progress.
So next time you look up at the night sky, think about Copernicus, the man who dared to put the sun at the center of it all. Thanks for joining us on this incredible journey.